So we are here looking at patterns of chemical reactions. So first we're going to look at combination or synthesis. It's called both. You'll probably see it more often called combination, but they mean the same thing. And so it's kind of like what it sounds like. You are combining multiple elements or compounds to form one thing. So in this first one, I combine sodium and chloride to form one thing. So I go from 2 to 1. I combine carbon dioxide and water to form glucose and a little bit of oxygen. That's photosynthesis, if you recognize that one. And here I combine lithium and bromine to form lithium bromide. So you're mostly going to see these as a 2 to 1 reaction. Occasionally, like this photosynthesis, you might have a byproduct, but the main thing we're forming here in this photosynthesis reaction is glucose. So you're combining two things into one thing is the key there. So then we've got decomposition, which is the opposite. You're breaking down. So if combining is building up, decomposition is breaking down. So in this case, I have my sodium chloride, one thing, and it breaks down into its two components. So this is mostly going to be a more complex reactant, like glucose breaks down into its less complex products. And again, it's typically going to be one thing breaks down into two or more things. There are always exceptions. Again, like this glucose one, it's got the byproduct of oxygen, but it's typically going to be one thing breaks down into two or more things. Okay, then we've got our replacement reactions. And there are two varieties of those, single and double. So let's talk about single. So we will typically see those called single replacement. Sometimes you might see single displacement. Again, replacement or displacement, it means the same thing. So in this case, think of it like you're doing, I had a student once who said it was like Mr. Steal Your Girl, right? So you've got iron here. Iron is going to kick out that copper. So now iron has bonded with the chlorine and copper is out by itself. So you're going to have one element replacing another element. And the one that got replaced is now going to be by itself. So again, think of it as the Mr. Steal Your Girl reaction. The sodium kicks out a hydrogen here. Now the hydrogen's by itself and the sodium is with the oxygen and the other hydrogen, the hydroxide. The nickel here kicks out the hydrogen. Now the hydrogen's by itself and the nickel is with the chlorine. So one element is replacing another. We've got double replacement, which is like a do-si-do. If you have your partner and someone else has their partner and you're dancing, and then you switch partners, that's like a double replacement. So you can see here the calcium and the silver, they switch because the calcium was with the chlorine, but now the calcium's with the nitrate. The silver was with the nitrate, but now the silver's with the chloride. So they just did a little swap. They swapped what anion they were with. So in all of these, you see it's a double replacement. The sodium replaces the barium, but the barium also replaces the sodium. So in the first one, we had something left out on its own by itself, but with double replacement, both things are still bonded to an anion. It's just they switched places. And then finally, we've got combustion. This one's fun, right? So combustion combines with oxygen. So look at all these, reacts with O2. You need O2 for combustion to happen. And typically, the products, typically we're going to see hydrocarbons reacting with oxygen, and hydrocarbon is a compound containing carbon and oxygen. And those ones are going to produce CO2 and water, CO2 and water. But it's not the only thing that could combust. So we have magnesium plus oxygen gives us magnesium oxide. Iron plus oxygen gives us iron oxide. And notice this could be also classified as synthesis. So if I saw these, I would probably first classify them as a synthesis or combination, but they are technically also a combustion. But ones like these, where it's a hydrocarbon reacting with oxygen to produce carbon dioxide and water, 100% combustion every time. But again, these last two, they are combustion. They are reacting with oxygen gas to release energy. But these first two are your more classic examples of combustion. And those are your 5 reaction types.